All right, so this second PowerPoint for the week is going to do two different things. One, it's going to show us how to do all this ARIMA modeling in SAS. And two, it's going to give us an actual example where we kind of like walk through the different steps that I kind of talked about in the previous slide or set of slides. All right, so this is a paper towels data set. I'm using a data set. I'll try to post it on D2L. I'll try to remember to post it on D2L so you can play around with it yourself if you want to. Might be a good way to kind of reinforce kind of what I'm doing here, because you'll see it's a little tricky how I go about doing it. So it's 120 weeks. So what would that be? That'd be a little bit more than 2 years of sales of some anonymous paper towel, and it's in units of hundreds of thousands. So I'll post a data set. It's an Excel file. The way the Excel file I think is set up is it just has a Y variable. There's no time variable in it, which we'll see is not that big a deal. We'll see how to work around that. And then what we're going to use is we're going to use something called, yeah, very exciting, all caps, multiple exclamation points, time series forecasting system. Hooah! So how do you do this? Well, it's one of those kind of things where it's almost weird that, like, I mean, that's how we've kind of raised ourselves, right? Most non-statisticians who practice statistics love programs like SPSS where they could just use like pull down menus. Excel works like that too. A lot of pull down menus in Excel. Right, we're used to coding what we're doing, writing out code to do a statistical analysis. However, there are pull down menus in SAS, and that's what we're going to use. And it's going to be kind of a little ironic that I suspect for a lot of us, actually using a pull down menu will feel a little bit more challenging, a little bit more difficult than actually writing code. I actually assure you it's not. If you want to play around with it, if you want to kind of Google it, I mean, heck, I guess you could even make it a presentation topic if you wanted to. There is a proc ARIMA, but proc ARIMA is easily one of the most complicated procs in terms of how it works and how it sets up. More complicated than anything we've covered in any class that I've taught. Right, most of our procs essentially, like their core thing is just a model statement, but proc ARIMA actually has like sort of three core pieces: this identify statement, this estimate statement, and this forecast statement. And all three of those pieces are very kind of profound in terms of what they do and how they work. Also, we'll see that like one of the most important things for like kind of building a time series is to look at like your scatter plot, to look at your SAC and SPAC, to be able to do that very quickly and easily. And we'll see that that's actually much easier to do using this time series forecasting system, this pull down system, than it is using like the proc ARIMA. It's very clunky to use that proc ARIMA to keep generating the plots that we need. And we'll see that this like pull down menu is actually very easy for doing that. It's maybe kind of the main reason for doing it. In practice, I often would use this kind of pull down menu, this time series forecasting system, to look at a lot of the graphs and kind of get a tentative idea for a model that I like. And then I might actually fit that model or refine that model using proc ARIMA. So this is what should pull up, right? If you go, and here we could see, right, in the very top, do you see, it says File, View, Tools, Solutions. So it's that solutions that you're clicking on to get to that time series forecasting system, and then it'll pull up that little window there, right? The the most cutting edge graphics that that the 1980s have to offer us. Yeah, so that's what it looks like. So you're going to have to pull your data set in. You should have read your data set in before you did this. So I did say a couple of slides back, first step is reading your data set. It's an Excel file, so using that import manager is probably the easiest way to do it. Remember, if you're doing this from home, you have to like use like Excel from like a workspace or something like that. I'm assuming you put it in your work library. So you've already imported or already read in your data set. So once you pull this thing up, what you're going to do is you're going to click Browse next to the data set. When you click Browse, it'll ask you to select a library, probably your work library, and then it'll ask you to pick the data set. So you gotta click that Browse to tell SAS, to tell the time series forecasting system what data set you want to work on. Then, right, you need a time variable. This particular data set doesn't have a time variable, so you're going to have to click that Create button. And I'll let you play around with it, but there's a lot of different options when you click the Create button. But one of those things is just to, it says something like create the time based off your observation numbers. And for this data set, that's perfectly fine. So that's what I ended up doing. And I think SAS will create a variable called date that just has the values 1, 2, 3, all the way to 120. You could probably leave that interval thing blank. That interval is a way of specifying your seasonality, which we're not going to mess with, but right, that's where you would communicate to SAS that you have quarterly data or monthly data, something along those lines. So let's see what the next few slides look like. I forget exactly what screenshots I put here. Okay, so this is what it looks like actually if you click the browse next to the data set. So, right, there's my work library, there's the towels data set. Actually notice here, right, it has that time ID thing. And I think unfortunately I created that time ID before I started doing the screenshots, sadly. So yours might be blank. All right, and then so there's the data set, there's my time variable, right? Interval of 1 just means that there's not really any seasonality that we're indicating or entering. Man, my memory's so rusty. I'm not sure what screenshots are coming up. But I'm a little nervous that maybe we're going to jump to the graph. So, right, once you do get your data set in, once you select your time variable, the first thing you're going to want to do is look at a scatter plot of your data. For just about any time series approach, right? The beauty of time series is that we can look at scatter plots. That is typically just two variables, some y variable and some t variable. So we almost always want to look at scatter plots. It's almost always our first step. So if you look at that interval line and you go all the way across, right, it says specify. And if you go even further to the right, there's like two little icons. The leftmost icon looks like a little bit like a little graph, right? It's kind of going upwards. Clicking on that button will create a scatter plot graph, which I don't think I do in the next slide, but I think I'll be doing in a few slides. So let's see. Yeah, so at some point, and I think it is when you click on that graph button, I apologize, you might have to play around. This is the downside of like not having code, right? Code is so black and white. I just give you code and you paste it in your thing and you run it and there you go, right? That's these kind of these little pull down clicks are a lot more ephemeral. But play around with it. If you run into trouble, shoot me an email. But when you select the graph, I believe that's when it'll ask you what your y variable is. And I think in this particular data set, it's just called y. So, right, I'm just selecting the variable y. Yep, and there's my graph. So what do we think? Do we think that looks stationary? Right, it needs to look stationary for us to build an ARIMA model. We can see, do you see the great paper towel depression of 1923? Things look pretty bleak, in fact. Yeah, don't ask me how. Looks like there was actually negative sales, right? Looks like there was negative sales back at like time point 61. I don't know. I guess there was a lot of returns that year. The answer is it's not stationary, agreed? It looks like what? It looks like a steady downward trend until we hit like the literal rock bottom, right? Like the paper towel industry's version of an alcoholic's rock bottom. And then, right? And then, but by the grace of God, right? Sales started climbing up, thankfully. So we have this downward trend and this upward trend, this kind of V shape. That definitely is not a flat line. So this is not stationary, not by any stretch. Well, so what do? Well, we said when our problem is trend, the common solution is to look at that simple difference or that first difference. How do we do that? Well, if you look above our graph, do you see that triangle button? That triangle is actually, I think, the capital Greek letter delta. In mathematics, delta refers to differencing. So clicking that triangle button will take the first difference for us. So I think I summarize this in the next slide. I think I say that this does not appear stationarity, so we need to try something. Let's try the first difference, and we'll see we do that by clicking that triangle button. That's very easy, right? Again, that's the appeal of this time series viewer, is it's so easy to like look at these graphs and to transform them. Yeah, not stationary. Yeah, so here I click that triangle. Notice now it says simple difference. This to me looks really good. It's a flat line. That much seems pretty clear cut. I mean, there's like a spike here and there. In fact, we see a spike around 60, another spike around 70. But with like those two exceptions, right, just about all other 118 observations all seem to be within kind of roughly the same kind of band of variation. So I would say that we have constant variation as well. That is, to me, and it takes a lot of practice to be able to do this, but to me, this looks like actually a really good stationary scatter plot. So, right, we have our sort of Z sub t now, and now we're ready to try to build our ARIMA model. Yeah, so conclusion, taking a simple difference seems to make the data stationary. So now we need to build our ARIMA model, right? We said we build our ARIMA model by looking at the SAC and the SPAC. So how do we do that? Well, now look to the right of our graphs. And so there's a few icons, right? It looks like 4 icons. The topmost one looks like that graph icon, and right below it, it looks like a kind of oscillating bar graph, doesn't it? Looks quite a bit like the autocorrelation and partial autocorrelation plots we were looking at in the previous set of PowerPoints. That's the icon you want to click on. And then that will give you the autocorrelation and partial autocorrelation plots that we were interested in. Okay. All right, so we want to look at those, and we want to think to ourselves, okay, right? I would say they both look to me like they're cutting off, is what I would say, which rules out that they're both dying down, right? That is, the autocorrelation appears to cut off at lag 1, and the partial autocorrelation, well, I don't know, right? So it kind of goes from 1 to 2. Maybe that's a cutting off, it's a dying down. The change from the partial autocorrelation 1 to 2 seems a little bit gradual, but then from 2 to 3, right, seems like a little bit of an abrupt drop. So that also seems like a bit of a cutting off. So again, it's not theoretically possible for both of them to cut off. So, right, we have to think which one seems to be cutting off the most. And then we'll assume the other one's dying down. What do you think it is? What would you guess? And again, this is tough. This is tough. It takes practice. It takes practice. And there are ways of checking and like sort of kind of checking yourself in these decisions. We'll talk about that in a little bit. So maybe write down what you think, which one's cutting off, and we'll see if we agree in the next slide. Yeah. So, like I said, SAC seems to be cut off after leg 1. SPAC maybe seems to cut off after leg 2, but that's impossible. To me, that SAC seemed to cut off the most, right? That SAC went from 1 to nothing pretty quick, whereas the SPAC kind of went from 1 to 2 and seemed like a little bit of a dying down, and then from 2 to whatever. So to me, the SAC seemed to cut down the most. And if you go back to our notes, I'm sure you probably haven't internalized it, but if you go back to our notes from the previous PowerPoint, you'll see that that implies a moving average model of order 1. Now, there's nothing wrong, right? If you're kind of like really going back and forth and you're like, I just don't see it or I don't know. Well, if it was the other way around, that might imply an autoregressive model of order 1 or 2. There's nothing wrong with fitting those models as well, right? And then you have these 3 different models and you can compare them by, right, these different metrics that sadly we don't have enough time to get into. But if you are actually in a situation where you needed that, you're of course always welcome to reach out to me and I can kind of walk you through it a little bit. So we've decided, right, a moving average model of order 1. How do we go ahead and fit that model? Well, we got to go back here. So you got to close out your graphs and go back to this. This was actually our original starting point for the time series forecasting system. And if you look in the top left of kind of like, well, in the bottom left, you see these 4 large buttons. The top left of those 4 buttons is a develop models button. That's what we want to do, right? We want to develop a model. So let's click that. And then you get something like this. So you have that big white space, and that big white space is actually really cool. So what you're going to do, I believe you right click inside the white space, and that will give you like a bunch of options. The option we're looking for is something like fit a Rhema model. But what's cool is you could actually fit a second, a third, a fourth. You could fill that white space up with like a whole bunch of different models. And it'll say the model on the left, and it will have some metric of that model on the right. And then it will rank those models by that metric. So notice where it says root mean squared error. That's the square root of MSE. That's a metric we talked about back in Stat 512. So what it's going to do, you can fit a bunch of models, and it will order those models by the square root of the mean squared error. It's kind of cool, right? For what it's worth, the usual metric that we sort models by is either the AIC, which is pronounced ick, or the BIC, which is pronounced bic. Again, we don't have time to really go into what those are, but you could Google them. They have their own Wikipedia pages. They are pretty important, like metrics for comparing models. So if you could find the time on your own, they might be worth looking up and learning about. Again, if you want a presentation topic, that might be a good one as well. So when I right click and I do fit a Rhema model, I'll get something that looks like this. Right on that right hand side, it says seasonal ARIMA options, right? Sadly, we don't have time to do seasonality, so we're going to leave that alone. But we have ARIMA options on the left, right? And so I can pick my moving average order. I could pick my autoregressive order, right? I could do both of those, which would be a mixed model. I could also tell SAS, right, what differencing needs to be done to get stationarity, right? In fact, right, when it's an ARIMA model, right, what does ARIMA stand for? The AR is autoregressive, the MA is moving average, the I is referred to like integrated. The integrated is essentially like how many differences you had to do to get stationarity. Right, so that middle thing, that differencing, that D, that's actually the I in ARIMA. Right, so a lot of times you'll write an ARIMA model some number, comma, some number, comma, and that's the order. It's that P, the D, and the Q. So for us, I believe that we decided moving average order 1. Our differencing was 1, not a mixed model, so we'll leave that P, that autoregressive, equal to 0. Now look at that intercept area. So SAS actually is a little bit weird. It kind of tries to like auto determine whether you need an intercept or not. It's actually not bad at it. Um, I think the default for this data set is actually intercept no. I always like to set it to yes to see whether or not it's significant. Time series models are a little different than 512. 512, we just always left the intercept in. It really doesn't matter too much one way or another. At least I've never seen an instance where it matters that much. But it does appear to be convention to remove the intercept when it's not significant. So I always put it in initially, and then if it's not significant, remove it. Oh, so there we are. Yeah. So here I set all that up. So I put a 1 for the difference thing, a 1 for the Q, left the P equal to 0, and then you can click on that OK button. Right, and then now I got a model there, right? And I can see its root mean squared is at 1.03. I think if you right-click the model, so right where it's like kind of highlighted in black, you can right-click that, and it'll give you like an option like View Model or something like that. And then here you go. So this is a graph of, so the blue line is the scatter plot of the time series, and the asterisks are our predictions. So, I mean, that's pretty cool, actually, isn't it? That this ARIMA model, right? It's not always obvious, like when you look at the model equation, what's going on, but look at how beautifully our ARIMA model actually chases that data. Very, very nice, isn't it? So you could click on like lots of different things, and right, again, I really do encourage you to download that PaperDAO's data set and do all these steps yourself. And then once you have this model up, click all those buttons on the right. They all do different things. The one I'm going to focus on is that beta hat, because that'll give us our coefficients as well as the significance of our coefficients. Right, so here I can see that, right, as expected, that moving average coefficient is highly significant. So that shows that was a good pick. It also shows the intercept is non-significant. So I don't know it's a big deal either way, but we might consider, right, going back, refitting it, and put intercept equal to no. Right, but otherwise that's our model, right? We have our model equation. And then, right, perhaps just as importantly, if not more so, the significance of the coefficients. So hopefully this is enough to get you started with kind of model building in terms of ARIMA models. Again, right, you could do an entire class with ARIMA modeling, or certainly time series modeling. So, you know, there is a lot of kind of side topics that sadly are left unexplored. But it hopefully gives you a sense of the language, at least the basic process for building a model. And then we'll have a little lab exercise that you could turn in that'll help you get a little bit more familiar and comfortable using this time series forecasting system.